1.7 day 2 is on solving absolute value inequalities. So when you're solving absolute value inequalities, you can rewrite this as a compound inequality and solve each part. But the question is when do we have and compound inequalities and when do we have or compound inequalities? So if we have the absolute value of x is less than 4, this is when we will have an and compound inequality. This is because, in my first case, when my absolute value is positive, I have x is less than 4. And in the case that it is negative, I have negative x is less than 4, which dividing a negative would flip this and would give me x is greater than 4. When graphing both of these on a number line, you are going to notice, negative 4, forgot to add that negative, that I would have negative 4, 0, and positive 4. Oops. Graphing both of these, I would have x is greater than negative 4 and x is less than 4, which, as you can see from the graph, this is an and example. So my final solution would be x is less than 4 and x is greater than negative 4. But in the case that your absolute value is greater than whatever's on the other side, this is when you will have an or compound inequality. Same exact process. My positive case would be x is greater than 4. And in my negative case, negative x is greater than 4, divided by a negative, I would have x is less than negative 4. If you were to graph both of these on a number line, you would see that I would have negative 4, 0, and 4. So I would have an open circle here at negative 4, shaded in the left direction, and an open circle at positive 4, shaded in the right direction. Since my two inequalities are pointing in opposite directions, this is an or case, so my answer would be x is greater than 4 or x is less than negative 4. So in conclusion, you know which type of compound inequality you are working with because ands are represented by less thans. The way to remember this is less than, and obviously the two symbols are your less than or equal to symbol. For or, these are the greater than symbols, but a way to remember that is by great or. And obviously those are represented by our two greater than symbols. All right. So I'm going to go through the two examples on page 1. I'm going to leave the 3 examples on page 2 for you guys to do on your own. So just like when solving compound absolute value equations, we need to make our two cases. So we have our positive case where nothing changes, and we have our negative case where we're going to multiply our absolute value by negative 1. So we'll solve both of these separately. For my left side here, I'm going to add 2 to both sides. And that's going to leave me with x is less than or equal to 10. On my right side, you can either distribute or divide your negative 1. I'm going to distribute this time. So that gives me negative x minus 2 less than or equal to 8. Isolate my variable by adding 2 to both sides. That's going to give me negative x is less than 10 divided by negative 1 divided by negative 1. Remember, whenever you divide by a negative, to flip your inequality symbol. And that's going to leave me with x is greater than or equal to 10. Once again, this is when we need to determine between our and or. Since our inequality is less than our equality symbol, our absolute value is less than whatever's on our other side, this is an end example. So I'm just going to write that down so we have it. And you can actually write that in your solution. Wait a minute, I made one mistake here. Let's go back on this side. I totally forgot to distribute my negative 1 there. So let's go back here. Made a mistake up here. So when distributing my negative 1, I forgot to distribute it to my 2. So I'm going to change that to plus 2 less than or equal to 8. My bad. So subtract 2 from both sides. That's going to give me negative x is less than or equal to 6. Now divide by negative 1. And I'm going to get x is greater than or equal to negative 6. That looks a little bit better. That way they're not the same. So I'm going to go ahead and write my inequalities above. So I've got x is less than or equal to 10. And x is greater than or equal to 6. Now I'll make my graph. So I'm going to put 6 on my left side and 10 on my right side. X is greater than or is less than or equal to 10. So I'm going to use a solid dot shaded to the left. And x is greater than or equal to 6. So I'll do a shaded dot shaded to the right. All right, let's go through one more example here. So for number 2, same process, but this one we do need to isolate our absolute value first. So I'm going to do so by dividing both sides by 3. So that'll leave me with my absolute value. The absolute value of x plus 4 equals 18 divided by 3, which is positive 6. Now that my absolute value is isolated, I'm going to make my positive and negative case. So in my positive case, nothing changes. X plus 4 is greater than 6. And in my negative case, I'm going to write a negative 1 out in front. All right, so solving my left side first, all I need to do is subtract 4 from both sides. And that's going to give me x is greater than 6 minus 4, which is 2. On my other side, I'm going to divide negative 1 first this time. Make sure you flip your sign as always when dividing by a negative. So that's going to give me x plus 4 is now less than 6 divided by negative 1, which is negative 6. Now I'll do the same as with the other side. Subtract 4 from both sides. And that's going to give me x is less than negative 1, 0. So to determine my and or, I'm going to look at my original inequality. In this case, I have a greater than sign pointing towards my absolute value. So this will be an or example. So for my solution, I've got x is less than negative 10 or x is greater than 2. I can go ahead and graph that. So I've got negative 10 and I've got positive 2. Both will have an open circle. Positive 2 is shaded to the right and negative 10 is shaded to the left. All right, so hopefully those two examples give you a decent idea of how to go about solving absolute value inequalities. Please write down these 3 examples on the second page here and give them a try on your own. Remember, isolate your absolute value first, determine your and or, and then go about solving both sides. All right, please try these 2 on your own. Come to class with any questions. Thanks for watching.